So let's take our next question, that is question number 10. As per the question, this belongs to section of electromagnetism from chapter magnetic effects of current. A rectangular coil of dimension 5 cm into 2.5 cm with 100 turns carrying current of 3 ampere in the clockwise direction is kept centered at the origin and in the exit plane. A magnetic field of 1 Tesla is applied along x-axis. If the coil is tilted through 45 degree about z-axis, then the torque on the coil is. So all the ingredients required for the torque is already given to us. Let's see what is the formula for torque which is required. So torque is basically mb sine theta, right? And for m, what is the magnetic moment? So you will write I, N, A. I is the current, N is the number of turns, A is the area, into B into sine of theta. Now let's see what are the values which are given to us. So from here, current I is given as 3 ampere. Number of turn is given as 100. Area is given as 12.5 into 10 to the power minus 4 meters square, right? For magnetic field, it is given as 1 Tesla and theta is given as 45 degree, right? Putting these values, you will get torque is equals to 0.27 Newton meter approximately. So let's see which is the best suited option. Among the 4 options given to us, option number 2 is the correct answer to this question. Now let's move on to our next question, that is question number 11. Now the question you see here belongs to section of mechanics from the chapter oscillation and waves. Here, as per the question, a simple pendulum oscillating in air has time period t. The bob of pendulum is completely immersed in non-viscous liquid and the density of that liquid is 1/16th of the material of the bob, right? Now, if the bob is inside the liquid all the time, its period of oscillation in this liquid will be. So, you first of all have to know the formula for time period here. For the oscillation of a simple pendulum, you can write 2 pi under root L by A effective, right? Now when it was in air, A effective was G. That's why the formula was 2 pi under root L by G, right? Now when it is inside the liquid, let's take this as equation 1. When it was inside the fluid, A effective will change. Let's take it as A dash. That would be total weight by total mass, and total weight would be F minus the buoyant force divided by mass. When you solve this, you will get this as m g minus v total into sigma of liquid into g divided by m, right? This would be A dash effective. Now, as you are aware with the question, it is given that sigma of liquid is 1/16th of the density of the body. That means if you multiply Vg on both sides, you will get V sigma L G, that is equals to V rho G by 16. And this V rho G is basically the weight of the body, that is mg by 16. Now let's put on this value here. So what you will get is A dash effective would be equal to mg minus mg by 16 divided by m, which would be equal to 15g by 16, right? So now the new time period would be 2 pi under root L by 15g into 16. This is the second equation. So from the two equations, we can say that 2 divided by 1, we will get t dash by t is equals to under root of 16 by 15 or 4 by under root of 15. So t dash would be equal to 4t divided by root of 15. Let's see which is the best suited option here. This is 15. So from the 4 options given to us, yes, option number 2 would be the right answer. Now let's move on to our next question, that is question number 12. The question you see here that belongs to section of electromagnetism from chapter electromagnetic induction. The total number of turns and cross-section area in a solenoid is fixed. However, its length capital L is varied by adjusting the separation between the windings. The inductance of the solenoid will be proportional to. So basically, the question is seeking the relation of self-inductance with the length of the solenoid. And you might be aware, let's take this as self-inductance. So it would be mu naught capital N square A divided by length of the solenoid, where capital N is the total number of turns in the solenoid, A is the area of cross section, mu naught is the permeability of free space. So you can see that the relation is inversely proportional. So option number 1 would be the right answer in this case. Now let's move on to our next question, that is question number 13.